All right, so for 5.4, we're going to talk about conditional probability. So conditional probability, so this would be the probability of F given E, is the probability that F occurs given that the event E has occurred. So things like this might be, what's the probability that somebody we pick is divorced given that we're going to pick a woman, or given that we have picked a woman? Things like that. I believe that was an example from one of our other sections. So to find the probability of F given E, we can do the probability of being E and F at the same time divided by the probability of E, or the number that occur in E and F divided by the number of E. And I do want to make a note here. So to determine if E and F are independent so that one doesn't impact the other, if the probability of E given F equals just the probability of E, or if the probability of F given E equals the probability of F, then the events are independent. So that would mean that even though we're given that F happened, it makes no impact. And again, events being independent means one doesn't have an impact on the probability of the other. Okay, so for our first example, suppose a single card is selected from a standard 52 card deck. What's the probability that the card drawn is a club? Well, let's first do that one. So let's do the probability that we're going to draw a club. Well, the clubs, we can think of it as 1 out of 4 suits, or we can think of it as 13 out of 52 cards, which is going to reduce down to 1/4. All right, and now suppose a single card is drawn from a standard 52 card deck, but we're told the card is black. So now we're being given the information the card is black. What's the probability that the card drawn is a club? So we're trying to find the probability that we have a club given the fact that we have a black card. So we can go through and determine the number of cards that are club and black, which, yes, I know all the clubs are black cards, and then divide that by the number of black cards. So the number of clubs and black, so just the number of clubs is going to be 13, and the number of black cards is going to be 26, which will reduce down to 1/2. And so keeping with the idea of independence, the probability of drawing a club versus the probability of drawing a club given that it's a black card, these aren't the same probabilities, so these two are not independent. Okay, for B, according to the U.S. Census Bureau, 19.1% of households are in the Northeast. In addition, 4.4% of U.S. households earn $75,000 per year or more and are located in the Northeast. Determine the probability that a randomly selected U.S. household earns more than $75,000 per year, given that the household is located in the Northeast. So I'm just going to write out the numbers that they've given us so far. So it's telling us 19.1% of households are in the Northeast. So the probability of picking somebody and them being in the Northeast is going to be 0.191. And then it goes further and says that 4.4% of U.S. households earn $75,000 per year or more and are located in the Northeast. So the probability of picking somebody that's in the Northeast and makes at least $75,000 is going to be this 0.044. And so it's asking us to determine the probability that the randomly selected U.S. household earns more than $75,000 per year, given that the household's located in the Northeast. So we're trying to find the probability that we're getting getting a person that makes $75,000 or more, given the fact that they're in the Northeast. Well, we've already got our information set up here pretty nicely for us, because we're going to have the probability of both of these, so the 75,000 and being in the Northeast, and then divide that by the probability of being in the northeast. So that's going to be our 0.044 over 0.191. So that's going to be about 0.230. And so again, it's asking us for the probability of that, and we're going to get that 0.230. All right, now let's look at health insurance coverage. So the following data here represents in thousands the type of health insurance coverage of people by age in the year 2000. So for part A, it's asking us what's the probability that a randomly selected individual who's less than 18 years old has no health insurance. So this is telling us that we're randomly selecting an individual who's less than 18 years old, and we're trying to find the probability that somebody less than 18 years old has no health insurance. So the given part is the 18 years old, so we're trying to find the probability that there's no health insurance, given that they're less than 18. So to do that, we're going to get the probability of no health insurance and less than 18, and divide that by the number of people that are going to be less than 18. So the number less than 18. So let me change that P to an N up here just to be proper. So this is going to be the 8,531 over, and the number of under 18-year-olds, if we were to go and add all these up, we're going to get 77,666. And that will be approximately equivalent to 0.1098. All right, so again, this is A, where we're given that the individual is less than 18 years old, and then we're trying to find the probability of no health insurance. Well, for B, it's just slightly different. So what's the probability that a randomly selected individual who has no health insurance is less than 18 years old? So we're going through, and it's telling us the probability that a randomly selected individual who has no health insurance. So we know that we're only looking at the people with no health insurance, and then we're trying to find the probability that's going to be somebody less than 18. So the probability that we've picked somebody who's less than 18, given that they have no health insurance, is going to be the number of people that are under 18 and have no health insurance. So that's going to be the same top number as we had up here, divided by the number of people with no health insurance. So we've got that 8,531 over, and then we need to total this up. And we're going to get 43,573. So we'll divide there. And then this is approximately equivalent to 0.19578, so 0.1958.